Hello everyone. In our last class, we discussed that rules for drawing the ray diagrams. Got it? What is that? Rule 1 is parallel to the principal axis, incident ray is parallel, then refractor ray pass through the focus. Second rule, if incident ray is passed through the focus after refraction, refractor ray becomes parallel to the principal axis. And the third rule, if incident ray is passed through the optic center, it passes undeviatedly. Got it? Right. Now here we are going to drawing image formation. Formation of various positions of object in front of biconvex lens. Okay, this is our topic. Image formation of various image formation of various positions of object in front of biconvex lens, right? Then first, object position. Right. In the first case, in object position, here at infinity, right? In infinity, we have to take two situations. If object is present at infinity, we will take two situations, right? In that first one, right, at object is at infinity now. In that first one, in this concept only, first one, a beam of light parallel to the principal axis. First position, object is at infinity only, right? In that beam, if object is at infinity, we will take incident rays or parallel to the parallel beam or not. If object is located at infinity at longer distance, we will follow the rays, incident rays, or parallel to each other, right? That parallel beam is parallel to the principal axis where the image is formed. That we are going to discuss. Got it, Nana? Right. This is convex lens. Okay. Symbolical representation. I will use symbolical representation while drawing the ray diagram. Okay. Right. Optic center. Okay. Focus, center of curvature. Okay. Focus, center of curvature. Here an object is at infinity, but a beam of light is parallel to the principal axis. It is passing, it is traveling parallel to the principal axis, right? Parallel to the principal axis, like this. We know that after refraction through the biconvex lens, they converge at focus. They converge at focus. Got it? They converge at focus. Right. Like this, the image formation will take place. Got it? If parallel beam of light fall on it, then they converge at a point. Here we use rule 1. To complete it, we use only rule 1. Right? Then here, characteristics of image or image characteristics. Image characters. Okay, image characters. Okay, image characters. First one, where it is formed now at focus. It formed at a focus. At a focus, right? The next, what type of image is this? Here, the image is formed by the really converging of refracted rays. No, here image is formed by the really converging of refracted rays. So that's why here we call as real image. Real image. Then image is real, and real images are inverted images. Inverted images. Inverted image. Real image is the inverted image. What is the size? Point size image. Point size. Got it? Point size image. If object is at infinity, a parallel beam of light fall on it. After refraction, they converge at a point. At that point, the image is formed. Right? From this ray diagram, we came to know that in this situation of the object, these lenses are used for as lens to raise the temperature. Got it? Then next one. Here we used then a beam of light parallel to the principal axis. In this object is at infinity only, but here second position. Here parallel beam of light, a beam of light parallel to the principal axis. Right? Here the beam of light is parallel to the principal axis. In position B, a beam of light is not a parallel to the principal axis. Got it? In previous case, it is parallel to the principal axis. Here it is not parallel to the principal axis. Got it? Then see. Okay. Convex lens. Identify the focus. In every time you have to identify the focus and a center of curvature. Okay. Got it? Then see here. Now the beam of light is not a parallel to the principal axis. In such case, here, for example, got it? I have taken parallel beam, but they are not parallel to the principal axis, right? In such cases, it was parallel to it. Okay, and they converge at this point. Here the image is formed. What size of image? Size of image is point size. Image characters, right? Then image characters. Characteristics of image. Okay, characteristics of image is formed at then see, from the point of image, draw normal to it. Then this total, that normal is meet at the focus. So this total is called as the area perpendicular to the focus is called a focal plane. What we call focal plane. It formed at focal plane. This is what? A focal plane. If rays fall from in this direction, the image is formed here, right? Then what type of image? Image is real, right? Real images are images inverted, and the size is point size. Okay, that's why these lenses are used to burn. Why? Because if then sun rays which fall on convex lens, that is focused to at one point to raise the temperature of the given object, to burn it. Got it? Right. Then that's what we call magnifying lens, right? Okay, these are the two positions. If object is at infinity, we have two situations. One is if incident ray, a beam of light is parallel to the principal axis, and second position, a beam of light is not parallel to the principal axis, right? This is one object position. Next, okay, now next position of the object we will taken as beyond the center of curvature, but not at infinity. Beyond the center of curvature means it considers infinity also, but here the object is not at infinity but behind the center of curvature. Object at behind the center of curvature. Beyond the center of curvature, where it is beyond the center of curvature. Beyond the center of curvature. Okay, right. Then here lens, convex lens, principal axis, optic center, okay, focus, center of curvature. We have lenses have two focus and two center of curvatures, no, then two we have to identify it. Okay, object is located at beyond the center of curvature, for example here. Okay, object position where the image is formed. From here, to form the image, we have to take minimum two rays. Got it? Right. First ray, the two rays, then we will take the rays which we discussed from rules, no, rule 1, rule 2, rule 3. Out of the three rules, I will take any two rays to complete the ray diagram, right? Okay, then ray which is parallel to the principal axis. You know that if incident ray is parallel to the principal axis, it passes through the focus. First one. Got it? Then next, here directly I will take if incident ray is passed through the focus. Incident ray is passing through the focus. Got it? After refraction it passes parallel to the principal axis or not? Here which rule I used? Rule 1 and rule 2. Rule 1 and rule 2. I used rule 1 and rule 2. Rule 1, if incident ray is parallel to the principal axis, after refraction it passes through the focus. If incident ray is passed through the focus, after refraction it passes parallel to the principal axis. Got it? Then from the point of intersection of these two refracted rays, draw the normal towards the principal axis. There the image is formed. Then this is called image. Got it? Right. Image characters. Okay, right. What are the characteristics of image? Then first one, location of the image, where the image is formed between focus and center of curvature. So you have to write between F and C. Got it? Right. Next, then image is real or virtual? It is a real image. Why? Because the image is formed by really converging of two rays. So here we have to take image is real. First one. Next, image is real, then image is inverted. Got it? Image is inverted. And the next one, what is the size? One, see the size of the image, object size and image size. So if we compare the sizes of the image and object, if we compare the height of the image and object, see image height is less. So that's why here we call diminished image. Got it? We will get diminished image. Okay. If you are, then you will get for 2 more questions. He will give object position at beyond the center of curvature, and you have to complete this ray diagram. You will get 1 more for characteristic, 1 mark, 2 marks. Right? Easy to get or not? Right. Then this is the third situation. Next. Okay. Next, I will take the position of the image, position of the object, right, at C. Object is at C, means on center of curvature. Right, see. Object, then here take a convex lens, biconvex lens, then principal axis, optic center, focus, center of curvature. Okay, then here object is located on center of curvature, Here I will use first ray parallel to the principal axis. If it is parallel to the principal axis, after refraction, we know that it passes through the focus. Okay, it passes through the focus. This is rule 1, right? Rule 1 says that if incident ray is passed through the focus, after refraction, it passes parallel to the principal axis. While drawing the ray diagrams, see, you have to use a scale to get straight lines. Okay, Nana? Right? Then, okay, here. And from the point of intersection, draw the normal. Then you will get the image. Use then here my line is little bit bending this way. Then see here. Okay, right. Then you will get image also on center of curvature. Here we have to write image characters as the first one is where it is located on C. Right. Then formed by the really converging rays only, no? Right. Then image is, I have to say image is real. And the next one, then image is inverted. Real images are inverted images. And the next one, what is the height of the object and image? You can see that height of the image and object is same, that same size image. Same size image. Got it? Then this is next position, right? Okay, Nana, right? At object at C, right? Get. The next, again I will change the position of the object. Position of the object. See here. Next one, object is between focus and center of curvature, right? Between focus and center of curvature in such cases, right? Then convex lens, optic center, focus, center of curvature, focus and center of curvature. Got it? Here object is located at between center of curvature and focus. Here I am going to use first rule, parallel to the principal axis. Okay, after refraction it pass through the focus. Got it? Right. The next, if second rule, I will follow the second rule. What is the second rule? If incident ray is passed through the focus, draw straight. Okay, if incident ray is passed through the focus, after refraction it pass parallel to the principal axis. It was parallel to the principal axis. Then draw the normal towards the principal axis, towards the principal axis, and it gives the image. Got it? Got it? Right. Then here I use two rules. If incident ray is parallel to the principal axis, after refraction it passes through the focus, and if incident ray is passed through the focus, after refraction it passes parallel to the principal axis. Take parallel. May it here it is appears a little bit curve, no, but use it as parallel. That's why what I am saying, use while drawing the ray diagrams, use scale, then you will get accurate positions. Okay, right? The little bit. Then see the image characteristics. It is again, it formed object between the, so it is formed behind the center of curvature. Okay, behind the C. Got it? Then here image is real. And one more thing, real images are inverted images. Inverted. And what is the size? You can easy to identify, enlarged. Right? Enlarged. This is one more position. Got it? Right? If object is located between center of curvature and focus, image is formed behind the center of curvature. Okay. Then next we are going to discuss one more position. Got it? Then here object is at focus, right? Now object is located on focus, then how it is forms? Biconvex lens, right? Optic center, focus, center of curvatures, okay, right? Now object is located on focus, at focus, or on focus, object at on focus, right? Here I will use first ray in case of object, then parallel to the principal axis, after it pass through the focus. Got it? Right. Here we can able to use the second rule. There is no chance. No, second rule is what? If incident ray is passed through the focus. Here it has any possibilities? No. So in such case I will use third rule. Third rule is says that if incident ray is passed through the optic center, like this, right? Optic center means it has no deviation. If incident ray is passed through optic center, it has no deviation, then they move a longer distance, so they converge at infinity. They converge at infinity. Then we know that image is formed at infinity. Okay, right. Next one, infinity, but it is forming with a real refracted rays only. No, then there the image is real, and real images are inverted. Image is inverted. It is formed at infinity, so its size is highly enlarged. Got it? Then if object is located at focus, then image is formed at infinity, real and inverted image, and it is highly enlarged image. It gives what image? Highly enlarged image. Okay, and the next and the last position, where the object is located between optic center and focus. Object is in between optic center, or otherwise optic center and focus. Object is in between optic center and focus. Then biconvex lens, principal axis, optic center, focus, center of curvature, focus, center of curvature, right? Here object is located in between pole and focus, sorry, optic center and focus. No, then I will take first ray parallel to the principal axis, it passes through the focus. Got it? Right. Second ray is pass through the optic center. Then here I will take rule 3, then it pass undeviatedly. Then see the diameter between these two refracted rays are increasing, so that's why these called as diverging rays. In such cases, to form the image, we have to extend backward. Then while expanding backward, the refracted rays, they meet at a point. From that point, draw a normal to the principal axis. then it gives the image. Got it? Got it? Then when I have taken two rays, then incident ray is parallel to the principal axis. After refraction it passed through the focus. Then next one I followed by rule 3. Then if incident ray is passed through the optic center, it passes undeviatedly. Then these two refractor rays are divergent. In such case, we have to extend the refractor rays in backward direction. If you draw in front direction, they never made no use. So in such case, then we have to extend in backward direction until they meet. The extended refractor rays backward, they meet at a point. At that point, we will get the image. Right? Now here we are going to write the characteristics. Then where it is formed? Same side. Right? Then here we will draw behind the lens, or otherwise same side of the object and image both are the same there. Right? Then in such case, what type of image is this? Actually it is forming by the really converging rays? No. Then we extended backward? No. By the image is formed by the divergent beam of light is called as the virtual image. No. So here image is divergent. Divergent image is our erect image. So sorry, not divergent, sorry Nana, that image is formed by the divergent. No? Then the image is virtual. Image is virtual. Okay, virtual image is our erect image. Erect image. What is the size? Size is enlarged or not? See, object height, then enlarged image. Got it? It is an enlarged image. Got it? Then here the image formation by the convex lens in various distances, various positions we have discussed. Now here have noticed that when object is at infinity, image is forming at a near lens. If object is coming closer to the lens, image is moving away from the lens. Have noticed it? If object is coming closer to the lens, image is moving away from the lens, like in concave mirror. Got it? And it is then convex lens is given different sizes. We got image is point size image, we got it, and diminished images, and the same size image, and enlarged image, highly enlarged images also we are getting by using by the convex lens. Got it? Then here you have to practice this various position ray diagrams. You may get as a long question, and this situation is very important. Out of all the 6 ray diagrams what we discussed, all are important, and out of that this is a very important. Why? Because only in this position we are getting virtual image. Got it? Remaining all position, when object is at infinity, we are getting real and inverted. If object beyond the center of curvature, we are getting real and inverted. If object on the center of curvature, we are getting real and inverted. If object between center of curvature and focus, we are getting real and inverted. If on the focus also, we are getting real and inverted. But in only one position, when object is located between the optic center and focus, then we are getting virtual image. Right? So that's why it is a very important figure. Right? Got it? Until now we discussed image formation with a convex lens. Now we are going to discuss by concave lens. Concave lens. Right, Nana? right. Here object at infinity, object at infinity. Here object at infinity means, again here we have two situations, right. First one is parallel to the principal axis, a beam of light parallel to the principal axis. Next one is not parallel. Okay, right. Here I will say, if a beam of light parallel to the principal axis, okay, a beam of light parallel to the principal axis, situation A, right. Then concave lens, right. Then okay, focus, center of curvature, focus, center of curvature. Here a beam of light is parallel to the principal axis. Beam of light is parallel to the principal axis. Okay. Then what I said, if beam of light is parallel to the principal axis, this is the position. If object is at infinity, we have to take parallel beam only. We discussed that. Then in this case, that beam of light is parallel to principal axis. Then after refraction, we know that concave lens is a diverging lens. Concave lens is a diverging lens. That means it travels, the rays are divergent. Okay, the rays are divergent. In such cases, we have to extend backward until they meet, and at that point, where they meet? They meet at a focus. They meet at a focus. Got it? Very simple or not? If a parallel beam of light parallel to the principal axis fall on a concave lens, after refraction they diverge. Refracted rays diverges or not? See, the diameter is increasing or not? It is moving towards Hanamkonda, it is moving towards Karimnagar. They are traveling in different direction, no? Right. In such case, we are going to write image characters. Statistics of image. Statistics of image. Right, okay. First one. Image is formed at focus. Image is formed at focus. Right. Here it is found behind the lens now, same side of the object now. Right. So it is images, in this case image is virtual. And one more thing, virtual images are images erect. Image is erect. And what is the size? Diminished. Okay, image is diminished. This is, got it? If parallel beam of light, a parallel beam of light which is parallel to the principal axis is fall on the concave lens, then the refracted rays or diverges, then that diverges refracted rays or extend backward until they meet at focus. That point at the focus, the image is formed. That image is virtual and erect and diminished image. Got it? Right. This is in first case. What is that? If a parallel beam of light is parallel to the principal axis. Right. Here a beam of light is not a parallel, if beam of light is not a parallel, okay, I will write again completely, okay. First question, beam of light or parallel beam of, here you can take a parallel beam of light, alright, parallel beam of light is not parallel to the principal axis. Right, beam of light is not parallel to the principal axis in such case, right. Then take a concave lens, okay, principal axis, optic center, focus, center of curvature, focus, center of curvature. Got it? It is not parallel in such case, right. Then it fall here and it fall here and it fall here. Then it diverges, travel in straight. This is third rule we discussed now. If incident rays pass a parallel through the optic center, it never get any deviation. Then here you can extend backward, that after extension we can observe that refracted rays are meet at a point. From that point you can draw the normal to the principal axis. The drawn normal is meets at a focus. Got it? From the point of intersection of refracted rays, when we extend it backward from the point of intersection, if you can draw the normal to the principal axis, then it meets at focus, then the image is formed at focal plane. This is totally focal plane. Now we have already discussed, no, right. Image is formed at focal plane, and here image is virtual and image is erect and diminution, right. Got it? If a parallel beam of light which is not parallel to the principal axis, in such case image is formed on a focal plane. These are the two situations. You have to practice it, okay, right. Next, object position, right. Here object position is between center of curvature to or behind the center of curvature, behind C2, object is behind the center of curvature to optic center, okay. Object is between from behind the center of curvature to optic center. That means whether you can keep the object behind the center of curvature, or object you can keep on the center of curvature, or object you can keep between center of curvature and focus, or object keep on the focus. If you can keep the object between focus and optic center, whatever it may be, the place is whatever in between center of curvature to optic center, if we can keep whatever at distance, you will get same kind of image, right? Now I will show it. Concave lens, principal axis, optic center, focus, center of curvature, focus, center of curvature. Got it? Here I kept the object here. I will take first one, optic center. First rule. Then incident rays parallel to the principal axis, and it diverges, no, it moves in that direction, right? Then next ray I will take as, if incident rays pass through the optic center, it moves, right? These two are divergent or not? In such case, what I have to do, then I will extend backward, right? Here these two rays are intersect at a point, no, there you can draw the image, right? This gives the image. Okay, for a given object, image is located here. Okay, then got it? Here, sir, you said you have taken, I have taken from behind the center of curvature, no? Then for your better clarification, I will take object here. You can take here, this is object, this is image. Okay, then you can take object 1. Here one more object I have taken, parallel beam, it passes in that direction only, no, right? Then from here you can take one more, optic center, it passes straight, no, where the image is from here for first object. Then here you can take object A, it is called object A. Here image A dash, here object B, let us object B. Okay, here image B. Okay, here I will take one more example, object I have taken on the focus, right? Same parallel beam, no, parallel to the principal axis, it passes through the focus, right? Then next here from optic center, then where image is here, then this is C, position C, right? Here I have to notice object at beyond the center of curvature and between center of curvature and focus, and see on focus. In all such cases, it is given diminished or not. Compare these two sizes, diminished one. If you compare these two sizes, diminished one. If you compare these two sizes, diminished one or not. Then finally, characteristics of image. Okay, right? Whatever in cases, then see here image behind the lens or same side of the lens, and that means same side where object is located, in that size only, right? And image is virtual, image is erect, image is erect, and one more, it is diminished. Have understood or not? Whatever it may be. Then if comparing to first image, second and third image is little bit enlarged, but overall comparison between object and image is diminished only, no, right? Object A and image A diminished only, object B, image diminished, object C and image diminished. Got it? So that's why. Then what you have to notice it from out of this ray diagram, then always the concave lens, biconcave lens, always the biconcave lens is produces the virtual and erect and diminished image, virtual and erect and diminished image. Got it? This is our class.